Good morning, everybody. I'm working for Veolia team in France, and our study comes under the framework of the microcore project and concerns the monitoring of fecal indicators and pathogens occurrence in river in France. Campaign samples were analyzed by microarray and in parallel by classical methods, and the comparison between microarray and classical methods results allows validation of the microarray. Today we focus on the classical methods results independently of the validation of the microarray to evaluate the health risk for recreational activities and drinking water consumption. Started in 2012, a 2-year monitoring of microorganisms and physico-chemical parameters was conducted in 3 river waters used for resource for drinking water production and for recreational activities. Various physico-chemical parameters were measured, in particular flow rate and rainfall. And
se vuole può anche accomodarsi, come preferisce. As you prefer.
Thank you. And microorganisms studied were Cryptosporidium parvum oocysts. Thank you. Giardia lamblia-cyst, E. coli, Clostridium perfringens, and adenovirus. All these microorganisms were concentrated using a concentration elution method, which allows the simultaneous concentration of parasites, bacteria, and viruses. 50 liters of river water were concentrated and 1,000 liters for drinking water using hollow fiber filtration on a cartridge. The cartridge is then eluted and the concentrate is collected, and it was further analyzed with laser scanning cytometry using fluorescent antibodies for both parasites or by quantitative PCR detection for bacteria and viruses. An important thing to notice, it's all drinking water sample analyzed, a total of 8, were all negative for the 5 microorganisms tested. So for the rest of the presentation, we focus on river water results only. Let's talk about occurrence and correlation between microorganisms. The first table presents results obtained for site A with a sampling season and the various concentration obtained for the 5 microorganisms. We found
You can use also the mouse if you want.
Yes. 7 out of 8 samples positive for at least one of the parasites, with a higher concentration measured for Giardia lamblia in comparison with Cryptosporidium parvum. We found 7 out of 8 samples positive for E. coli, which is the highest concentration measured in comparison with 4 other parameters. All samples were positive for Clostridium, and 5 out of 8 were positive for adenovirus. Spearman correlation test was performed, and the second table presents the correlation coefficient obtained for the microbial parameters with a significant correlation in bold. we found a positive correlation between Cryptosporidium parvum and Giardia lamblia, a positive correlation between Giardia lamblia and Clostridium perfringens, and a positive correlation between E. coli and adenovirus. All these correlations suggest a common fecal pollution source. In the same way, for site B, 3 out of 8 were positive for Cryptosporidium. All were positive for Giardia and for E. coli. 6 out of 8 were positive for Clostridium perfringens, and 7 out of 8 were positive for adenovirus, with a higher concentration of adenovirus in comparison with the two other sites, A and C. Like for site A, we found higher concentration of Giardia lamblia in comparison with Cryptosporidium parvum, and the statistical tests show a negative correlation between Clostridium perfringens and the temperature, suggesting a prevalence of this bacteria when the temperature is lower. In the same way for site C, 3 out of 8 were positive for Cryptosporidium and 6 out of 8 for Giardia, with, like for the two other sites, higher concentration of Giardia lamblia in comparison with Cryptosporidium parvum. It's important to note that the site C is least contaminated in comparison with the two other sites. 7 out of 8 were positive for E. coli, Clostridium and adenovirus. And like for site B, we found a negative correlation between Clostridium perfringens and the temperature, suggesting again a prevalence when the temperature is lower in winter. Now let's talk about the seasonality of microorganisms, which represents the higher occurrence according to the season. The seasonality was treated only through site A, which is the most contaminated, but results and conclusion remain almost the same for the two other sites. You found on the right of the graph the major occurrence of microorganisms according to the season. The most important things is that lower occurrences were measured during summer, when the highest levels of recreational activities occur. Previous studies have already shown that highest occurrence of both parasites occur when precipitation are most important and when the temperature are colder. We measured the highest occurrence of adenoviruses in spring, which is middle temperate season. This could be explained because the maximum host excretion occurs in summer, when there's a maximum of recreational activities and human contact water, but the maximum survival and infectiosity occur in winter, when the temperatures were lower. Land use data were also collected to try to identify the pollution sources and to interpret the behavior of the different microorganisms. In bibliographic studies, the most probable source of contamination is due to human and farming activity, and this observation is confirmed for site A, for example. At this site, we found not less than 8 wastewater treatment plants releasing into stream in a distance of 20 km maximum, with capacities comprising between 2,000 and 50,000 inhabitants. This site is composed by high proportion of agricultural territories, 55%, with a probable manure spreading. And the site is surrounded by two of the largest regional natural reserves, with recreational activities like horse riding upstream to the sampling point. We also measured at this site highest proportion of an important flow rate during the sampling campaign, so leaching of soil from agricultural territories or forest is the most probable source of contamination. The health risk assessment was also evaluated for recreational water activities. We used two dose response models to calculate the health risk assessment. These models allow to relate the probability of becoming infected to the mean dose ingested. The first is named the exponential model. Parasites and viruses tend to follow this model, so we used it for Cryptosporidium parvum, Giardia lamblia, and adenovirus. And the second model is the beta poisson model. Bacteria tends to follow this model, so we used it for E. coli. We take into account the maximum concentration found during summer for the calculation risk, because the health risk associated with the ingestion of contaminated surface water is the most important in summer when recreational activities occur. The probability of becoming infected was calculated for two categories of swimmers: adult with primary contact or child with primary contact. The mean dose ingested was calculated considering an average volume of 16 milliliters for an adult and 37 milliliters for a child. We found the probability of becoming infected low for parasites, inferior to 1%. In the same way, the probability of becoming infected for E. coli is very low, and it's important to note that the concentration levels found for E. coli were also below the threshold of the European Directive for Bathing Water, even in winter where the concentration were highest. For adenovirus, the probability of becoming infected is the most important, varying from 1 to 10%, in particular for a child at size C. But for the calculation method, we used a detection method by qPCR, by a quantitative PCR, which probably overestimates the concentration of this microorganism. And the R value, the infectiosity parameter for the exponential calculation, is calculated for the type 4 adenovirus and is not representative of all the species of adenovirus. So we probably overestimate too the concentration and the probability of becoming infected for adenovirus. The risk for drinking water consumption was also theoretically evaluated. The table presents the theoretical removal of drinking water treatment for each microorganisms in bibliographic data. The average concentration per liter found for the 3 sites, and then the microorganisms average that may enter the treatment plant every day, considering the average concentration per liter found. considering the microorganisms quantities that may enter the treatment plant every day, and considering a daily production of 750,000 cubic meters of drinking water, and the log removal of the treatment of drinking water, a theoretical absence of microorganisms is expected in the finished drinking water. So an acceptable level of risk could be due to malevolent acts, deficiencies in water treatments, or problems occurring during maintenance operations. To conclude, for all the 3 sites, we found lowest concentration for both parasites, Cryptosporidium parvum followed by Giardia lamblia, middle concentration, intermediate concentration for Clostridium perfringens and adenovirus, and for all the 3 sites we find highest concentration for E. coli. We also found that the correlation between microorganisms were different depending on the sampling sites. It's not the same in all the cases. Lower occurrences of microorganisms occur during summer, and it's a good thing because it's in summer that there's a maximum of recreational activities. The most probable contamination sources is the leaching of soils or the presence of wastewater treatment plants near of the sampling site. The risk for recreational activities is inferior to 1%, except for adenovirus, varying from 1 to 10%. So there's a very low probability of infection by this microorganism in the studied areas. Taking into account the theoretical calculation, an absence of a microorganism is expected in finished drinking water with the removal levels, theoretically. The result of this study, obtained by classical methods, suggests that the multiplex microarray method could be an asset for water quality monitoring. For your information, publication of this result is actually under completion. And I would like to thank quite particularly all the partners and teams of the MicroAqua project, with whom I was pleased to collaborate during the 3 last years. Thank you for your interest.
Grazie. There are questions?
Just a comment. In order for a better comprehension of the origin of the source of infection by Giardia crypto,
yes,
should be probably better entering in details in the identification genotypes first. To, for example, make have some suggestion about the zoonotic or interhuman origin.
Our quantitative PCR detection for adenovirus is for all species. You tell me for adenovirus?
No, I'm speaking about Giardia and Cryptosporidium.
Giardia and crypto. Yes, it's we try to find near of the sampling sites the number of wastewater treatment plants which could release into streams and.
No, my suggestion is devoted to the identification, the more specific identification inside the species, because inside Giardia lamblia or duodenais there are many genotypes.
Yes, but we don't no. No.
Other question? Okay, very interesting your study, also because maybe a contribute to cultural and regulating services for drinking water, for recreation use of sites and so on. Thank you very much.
Yes, thank you.
Okay.